Yeah, the recording is started, so you can write your roll numbers in the chat box.
स्टँडी आणि कॉन्फरन्स हॉल म्हणून लागला आपल्याला.
नाही, तो कशाला?
फक्त स्टँडी.
स्टँडी फक्त घेऊया. हा?
कॉन्फरन्स हॉलला मोठी कीपॅड लावू, दोन्ही साईडला चालतेच.
हा, तेच की पीपीटी वरती डिस्प्ले करू. यस यस. So, good afternoon. Am I audible? Can someone respond? Am I audible?
Yes, sir.
Yes,
Hello.
sir.
Okay. Okay. Right. So why today's strength is less? 34 only. Okay, some of me attending this Koditas, right? How many of you have done with Koditas group discussion round? GD is going on. Okay. Right. So we were discussing about the different characteristics of embedded system. In the last lecture, I told you we have started with the second unit. Second unit is introduction to embedded system for IoT. Right. So here we will be discussing the embedded system which is used in IoT. Right. So let me quickly once again summarize what we have seen in the last lecture. These are the contents. Let me check. Yes. Yeah. Now the screen maybe it is visible to you. Right. Check it out once. Is it visible? Right. So this is the unit, second unit, embedded system for IoT, right? And I have given you the name of book that that has to be referred here is Internet of Things by Raj Kamal. This is Internet of Things by Raj Kamal, and the syllabus of this second unit is this one. Here we need to understand what is embedded system. Then we will see different components of an embedded system. Then basics of microcontroller, because there are embedded system which are based on microprocessor and microcontroller. So basics of microcontroller is to be considered here. Then basics of Linux based embedded system. So the embedded system, two categories are there. One is microcontroller based and second one is Linux based. Then various embedded platforms used in IoT we will deal with, and at the end we will discuss the various IDE. IDE stands for Integrated Development Environment. So various IDs that are there, that are available, we will discuss at the end of this unit, right? So initially, we started our discussion with this concept of embedded system, which is actually a combination of hardware and software, and which is designed to perform a specific task. One of the example I told you is a washing machine. So washing machine is an is a type of embedded system designed to perform the operation called as a cloth washing, right? And it will perform the same task. It will not do any other tasks like cooking, like playing music. All those functionalities are not associated with the washing machine. So washing machine is an embedded system. You can refer this as a combination of hardware and software. So hardware, in that you may have that entire casing of that this one washing machine. Then housing, complete housing of that washing machine, then motor, then whatever propeller that it contains, along with the control unit and some front panel and control buttons. All those comes in the hardware part, and whatever software is written on the computer, on the controller of that control panel, will be treated as a software. So this washing machine is nothing but a combination of hardware and software. So similarly, I can give n number of examples, but here we will talk about the characteristics of embedded system. In that, I have discussed around three characteristics already in the last lecture. That is single function, tightly constrained, and reactive and real time, right? So single function means it will perform only one function, right? And tightly constrained means there are many restrictions on the design part of that embedded system. And then we talked about reactive and real time. So can someone tell what is reactive? Upendra is there? Upendra.
Yes, sir.
Yeah, what is reactive? Have you met that person who did some comment in the chat box?
No, sir.
You meet him earliest possible, huh?
Yes, sir.
Okay. Then real time. Reactive means whatever action you are creating, for that there would be a reaction. So as far as this control system, control unit is concerned, when you apply the input, there has to be output. So in response with input, production of output is nothing but reactiveness, right? And the next terminology is real time. Real time means what? Without any delay. So if once the input is provided to the system, it should produce the output without any delay or minimum amount of delay. That is what the meaning of real time is, right? So system has to be a reactive and real time. Now microcontroller. So this point onwards we will discuss today. Microcontroller based system is nothing but a kind of system which have a brain. This analogy you can consider, right? So the system will have a brain, and whatever things will be taught to that brain, whatever hardware associated with that brain, it will be followed accordingly. Means what? Suppose I receive input on pin number 1, I will produce output on pin number 10. Suppose I receive input on pin number 2, I will give the output on pin number 11. So similarly, you can have your own mapping, you can have your own algorithms to perform certain tasks, certain critical task, in fact, I should say. Or you can wait for the interrupts. When the interrupt would occur, right? So very nice word I have just now told you, interrupt. So this is right moment to understand the working, understand the meaning of interrupt. You might have seen these interrupts in a microcontroller subject or in embedded systems. So can Can someone tell me what is interrupt? What is an interrupt? Nobody want to tell? What is interrupts? Very simple question, and I think every electronics engineer should be able to answer this. What is interrupt? Breaking the routine. Okay, good. Amit ji, you are very much close to the answer. Anything else?
Stopping the process.
Okay, stopping the process. Okay. Breaking the routine. Okay, breaking the routine, stopping the process. No. Amit and somebody else has said the same meaning, but sorry to say that the answer is wrong. Breaking routine, they are not related with the interrupt. Okay. Stopping of process is also not related with the interrupt. Let me tell you what is interrupt. Interrupts are a kind of obstacle. Interrupts are a kind of obstacle, but there is a clear border between the word obstacle and interrupt. Interrupt cannot be obstacle, and obstacle cannot be interrupt. Let me tell you why. Because interrupts are desirable. Interrupts are desirable. Stopping the process for short time. Okay, now it's approximate answer. Stopping the process for short duration of time. Let me tell you what is an interrupt. Interrupts are the obstacles, but they are desirable interrupts. They are desirable obstacles. For example, let me tell you the process, and then I'll come to you desirable, non-desirable thing. So interrupt means, suppose I'm teaching to you, right? So that means that you can consider it as a main program, right? So my processor is doing the same task in a main program, that is what teaching you. I'm continuously in one way I'm teaching you. So this is my main program. Teaching you is the main program. Now let's assume somebody calls me. Somebody make a phone call to me. So what will happen if somebody makes a phone call to me? If somebody makes a phone call to me, then what will happen? I will stop current execution. Means what? I will stop teaching you. And what I'll do is I will receive the phone call. So for doing that, what I'll do is I will mute my mic, right? So what I'm doing is I'm stopping the current execution. I'm interrupting the current execution for short time. Ashwini Patil rightly mentioned, for short duration of time. And in between, after stopping the main program execution, what I'm doing is I am attending that call. Means what? I am entertaining that interrupt. Right? I am entertaining that interrupt. And what will happen after complete execution, or what will happen when I will just cut off the call? I will when I will finish up with the call, what I'll do is I will put the phone back to its position, and I'll come back to here, and then I will unmute myself, and then I will start teaching you. Right? So in short, when the main program is under execution, and suddenly if the interrupt is occurred, then main program execution is stopped, and immediately after that the interrupt is being served. Whatever interrupt is whatever interrupt is occurred, that will be served, that will be entertained. And after entertaining that interrupt, again the main process execution will start. Right? So little bit technical. suppose you're using processor or controller, and you're executing main program. So during main program execution, suppose the interrupt is occurred, what happens actually is your program counter actually points to the instruction which is going to be executed next, right? Program counter will point to the instruction which is going to be executed next. मग इंटरप्ट आल्यानंतर काय होणार आहे, तो प्रोग्राम काउंटरची लोकेशन एका स्टॅक मेमरीवरती स्टोअर होईल. ठीक आहे. And program counter will be loaded with new address called as a vector address, which is associated with that interrupt subroutine. Okay. So whatever address is assigned for that interrupt, for example, in case of 8051, you might have seen those 5 interrupts, right? External interrupt 0, external interrupt 1, timer 0, timer 1, serial. So those 5 interrupts are having 5 different vector addresses. So upon arrival of any one of them, associated address will be loaded in a program counter, and program counter will execute the instructions which are stored from that address onwards. After completion of that interrupt service subroutine, आपण याला काय म्हणतो, जे इंटरप्ट आल्यानंतर एक्झिक्यूट होतं त्याला काय म्हणतो, इंटरप्ट सर्व्हिस सबरूटीन. So after completion of that interrupt service subroutine, again program counter is loaded with the content of stack which has been previously loaded, right? That means exactly from the location where it has been stopped. इंटरप्ट आल्यानंतर एक्झॅक्ट जिथं प्रोसेस थांबली होती ती लोकेशन परत एकदा सचिन ती लोकेशन परत एकदा प्रोग्राम काउंटर मध्ये लोड केली जाईल. उचला इथंच उचला. So the same thing will start execution immediately. Achha. Right. So after coming back from the interrupt service subroutine, it will execute the main program. So this is how the interrupt works, and where the interrupts are possible, it is possible only if we are using microcontroller or microprocessor. That's why our embedded system must be microprocessor or microcontroller based, right? So that is why I have written here, I have mentioned here, the embedded system must be microcontroller based. That simply means it has to have a microcontroller or processor inbuilt. Right. So next one is memory. Right. So sometimes we need to measure the parameters, and for that reason we have interface the different sensors, and followed by those sensors we have different signal conditioning units like instrumentation amplifier or Wheatstone bridge, or let's say potential divider. All those circuits provide the data in let's say analog form. That analog form is to be converted into digital, and that digital data most of the time we need to store the data, right? So example I can give you, temperature or let's say weather forecasting systems. In weather forecasting systems, what exactly happens is they used to sample the data of daytime, right? So let's say in a 24 hours, how the data related with the temperature gets varied. Let's say in the morning 6 o'clock, what would be the temperature? Let's say 22. Let's say at 9 o'clock the temperature would be 23. At 12 o'clock, let's say temperature would be 24, right? Let's say at 3 o'clock the temperature would be let's say 35. At 6 o'clock in the evening the temperature may go down, and 9 p.m. again the temperature will go down. So you can easily sample those data at different instants of time, and you can have some prediction for tomorrow's weather, right? So if I come to know that this would be the temperature at this particular time, I can say that tomorrow at this time this would be the temperature, right? So somewhere here, somewhat here and there, approximation is accepted as far as weather forecasting is concerned. Actually त्यांचे रिपोर्ट कधीच खरे निघत नाहीत. एखादी सुनामी वगैरे कधीच ते त्यांनी आधी सांगत नाहीत. तरी पण we can rely, they are approximate predictions, and this is how actually the predictions are made. So for that reason, what is important, you need to save the data. You need to get the data from the in sensors, and you need to save it on the memory, and hence the memory is required. So embedded system must have the memory. Then second last one is connected, right? So your embedded system must be connected all the time. It should not get disconnected. When this kind of examples are there, like automotive braking system. Suppose your impact sensor, or let's say distance or object sensor is getting disconnected from your control unit. What would happen if the impact sensor or obstacle detector won't work in case of automotive system, automatic braking system? Your vehicle will not identify the arriving obstacle, and it will not respond since the sensor is not connected. So everything has to be connected, like sensors, signal conditioners, all the interfacing units, then actuators, whatever you have applied as the output have to be connected. So embedded system will work only if it is fully connected. And last but not the least, as far as its definition is taken into the consideration, it's a hardware and software system. It's a combination of hardware and software system. So I hope it is clear with everyone. If you have any doubt, you can ask. If no doubt, let us proceed further. So next point of our discussion is different components of an embedded system, right? So I told you what are different components of IoT. In that I told you first component is embedded system. Then second component, can someone tell me? I told you the different components of IoT. What are different components of IoT? First one is embedded system. Then second one, can someone tell me what is answer? What is that answer? What are different components of IoT? If somebody knows, please tell me the different components of IoT.
Network system, database management system.
Okay. Let me tell you once again. Rather, I'll show you the different components, because we have seen that, and still none of you is actually able to answer the correct components. Yes, so I hope this is visible. First component in that I told you is embedded system, right? Then second component is sensor. Sensor is the second component of IoT. Then third component is communication system, right? In that we have seen lot of communication systems. And finally the cloud. So apart from that, you can also add internet as one of the component, or you can also say a communication system, actually, which is considered here as well. But whatever things are included in IoT, that can be a part of or that can be a component of IoT, right? So majorly we have four components. One is embedded system, second is sensor, third one is communication system, and last one is cloud. Now here once again I would like to focus on the slide which I have shown you, different components of an embedded system. Now here in the embedded system, again you will find some of the hardware part. Now so embedded system will have following components, but before that, let me tell you, embedded system is a part of IoT. So whatever T diagram you are able to see here, whatever tree diagram is shown here, this is nothing but a component of IoT itself, because embedded system is the first component of IoT. So when I talk about IoT, its first component is embedded system, and then if I talk about components of embedded system, it is divided into two major groups. One is application, second one is platform. Now in embedded system, we have those two categorization, application and platform. Now this platform is divided into two groups. One is hardware, one is software. Now can someone tell me what are different embedded system platforms that you know? Do you know any embedded system platform? I have discussed with you regarding this as a part of, let's say, as a part of content beyond syllabus. Different embedded system platforms. So can I say platform, example of platform is Raspberry Pi, right? So this Raspberry Pi will have hardware and software. So that is why platform called as Raspberry Pi will have hardware and software components. Now in hardware, what are different things that we have? In hardware we have sensor. Then what is the role of sensor? What is the role of sensor?
Sense and get the input.
Correct. Role of sensor
Get the
is
input.
to get the input. Then next one is ADC. ADC will convert it in digitized form. Then processor, it will process the data. If it want to save, if it's having a provision of memory, it can save the data. Then DAC will convert back into a analog form, and then actuators. So the hardware, let's say Raspberry Pi, will have these kind of things. If all those things are there with the hardware, we can call it as a complete system that can be used in a platform, right? So your Raspberry Pi needs some sensors to get interface, let's say if you are trying to build let's say healthcare monitoring, in which suppose you want heart rate sensor. So heart rate sensor is to be interfaced with GPIO pin, right? So ADC facility is there in Raspberry Pi, or if not, you can directly get the sensor which produce the output in digitized form. Then the data can be stored on Raspberry Pi. Then DAC, if not required, then you can have some of the drivers and ULN ICs, so that whatever things are there next to that can be driven based on the input readings from that sensor, right? But what is the important here? What plays the important role in this complete process? The thing which is important here is software, without which the hardware is useless. I hope it is clear. The important part of this is software. Unless and until you teach him how to behave, the hardware will not behave in any of the manner, right? So software defines what to do, what not to do, when to do, how to do. Everything is defined in the software. right? Now here I have categorized software in 3 parts basically. So what are those 3 different parts? Those 3 different parts are so the 3 different parts of the software are bootloader, operating system, and system program. So can someone tell me what are those 3 different categories? What is the distinguishing point? How we can identify it's a bootloader program? How you can identify it's a operating system? How we can identify it is a system program? Can anyone tell the difference between those 3 categories of softwares? Yeah, nowadays mobile application is coming into the picture, but for now, let's take only those 3 things into the consideration. So system program, operating system, and bootloader. Quickly, just tell me the difference. Excuse me, I need to receive this phone call. हेलो, हाँ मैम बोलिए ना. नहीं, लैपटॉप घर पे होना है बोल के आपने बोला था ना. अच्छा अच्छा, मैं उनको क्या बोला कि अगर 2-3 बच्चों के साथ रहेगा तो चलेगा, आप बस जाके आओ. उनके उनके घर पे है. अच्छा 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 अच्छा. तो मेरे ख्याल से 2-3 बच्चों ने वो लैपटॉप लेके गए हैं वहां पे. मैं एक बार चेक करता हूँ. यस यस यस. नहीं वो कम्युनिकेशन गैप मेरी तरफ से रह गया है, क्योंकि कुछ बच्चे बोल रहे थे कि लेके जाएंगे. मैंने बोला कि 2-3 लोगों के पास रखो, सबको लेके जाने की जरूरत नहीं है. बाद में जब आप वहां पे ज्वाइन होंगे तब आपके साथ लैपटॉप होना जरूरी है, ऐसे मैंने कम्युनिकेट किया था. राइट. यस यस यस. और सर से बात हुई मेरी, उनका ऑफर का क्या कैसा करना रहेगा? नहीं, जो भी आज वहां वहां पे सिलेक्ट होंगे ना, उनका उनका. अच्छा अच्छा. क्योंकि सर से सुबह में बात हुई मेरी. सर बोल रहे थे कि आप एक बार कहकशा मैम से और स्नेहल मैम से बात करके देखो. शायद वो शॉर्ट लिस्ट बाद में आपको भेजेंगे, जो भी सिलेक्टेड रहेंगे सर भेजेंगे आपको. उस यस, विल टॉक आफ्टर दैट. राइट. ओके फाइन. Hello. Am I audible?
Yes, sir.
Okay, I thought I think I forgot to mute. सगळ्यांनी ऐकलं वाटतं काय बोलतोय. ठीक आहे. इन बिटवीन मला एखादा कॉल आला तर काइंडली एक्सक्यूज मी, बिकॉज HR चे वगैरे कॉल येतात, सो आय कॅनॉट ड्रॉप. थोडस काइंडली बेअर विथ मी, बिकॉज आजचा आपल्या रिलेटेड नव्हता, पण इलेक्ट्रॉनिक्सच्या रिलेटेडच मोस्टली कॉल येतात आणि आय नीड टू अटेंड. राईट. सो आय होप यू अंडरस्टँड. Right. So this is what we are talking about. Bootloader. Bootloader is the program which is required to initialize the hardware. Bootloader is used to initialize the hardware. Now tell me, what does this operating system do? Or you can say, what is the role of operating system? So can someone please Google and tell me what is the role of operating system? Bootloader initialize the hardware. Next, what is the role of operating system? What is
It
the role of?
manages computer's memory.
Okay, it manages computer's memory. Anything else?
It connect user to computer hardware.
Okay, good. It connect the user to computer hardware. Very nice. Anything else?
Communicate with the computer.
Communicate with the computer. Okay, good. That is also a role of embedded system. Okay, so all those answers are very close. In fact, I can say here they are very much close answers. And let me tell you what is the role of operating system. Operating system makes the hardware accessible to the user. So because of operating system, you will be able to interact with the CPU. You will be able to interact with the screen that you are able to see. So operating system provides those functionalities. And what this system program does here? System program provides all the required resources to the application. Now tell me, where is the application in this diagram? It's just below that embedded system word, right? Because it is main part of embedded system. Application. Application means what? It's a utility program that provides different services to the user. Right? I hope you understood difference between all those four. Actually, software is divided into three groups: bootloader, operating system, and system program. And one more is there, that is application. All of those four are the part, they are kind of softwares only. Right? This application is also a software. This bootloader is also a software. Operating system is also a software, and system program is also a software. But they are different in their functionalities. Bootloader will initialize the hardware. Operating system will make user to access that hardware. System program will provide all the resources for this application. Right? So whatever resources are provided by system programs, application is nothing but another kind of software which is providing different utility, different services to the user. And example of this application is Google Meet. Example of this application is WhatsApp. Example of this application is Gmail. Right? So these applications will provide you different services, different utilities. Right? I hope the difference between all those four are clear. So these are all the types of different components of an embedded system. So let me quickly revise once again. Embedded system is one of the component of IoT. Now, here we are talking about components of embedded system. Embedded system is broadly divided into two categories. One is application, second one is platform. Application is nothing but a software which provides different services to the user. Whereas platform is nothing but a combination of hardware and software. In that, hardware will have which may consist of sensor, ADC, then processor or controller, then DAC and actuators. You know the working of all those very well. In software, it is divided into three groups. One is bootloader, then we can have operating system, then we can have system programs. Bootloader will initialize the hardware. Operating system will allow you to interact with the hardware, and system program will provide different resources to the application. Is it clear? Is that clear? Any doubt? If you have any doubt, you can ask. Any doubt?
No, sir.
Okay, if no doubts, then let's proceed. Next point is basic structure of embedded system hardware. Okay, so just now I talked about this embedded system hardware, right? So this is what the embedded system hardware is. So आधीची जी ट्री डायग्राम होती त्यामध्ये जो हार्डवेअर दाखवला होता, that is just made in a like block diagram. In this block diagram, what you can see is sensor. So sensor will grab all the physical parameters that it can and produce the output, which is given to analog to digital converter. So this analog to digital converter converts that data into digitized form. So here it will either send it to the processor, or at the same time it can save it on the memory. If sensor output is digital, directly the sensor output is stored on memory. So that's why two arrows are going to be there with the memory. So processor, what it does is, if it want to process the data in real time, it will take directly the input from analog to digital converter. And if real time operation is not expected, then the data will be stored on memory. Then as and when required, the data will be gathered from memory to the processor. Then processing is done, and based on that, the output will be produced. This output is given to the digital to analog converter, which will convert that digitized data into analog signal. So this analog signal is required to actuate the actuator. Actuate the actuator means what? Suppose you are using relay, or suppose you are using a driver IC. So to excite that driver, or to energize that relay, you should produce some signal, and that signal has to be in the analog form. So this analog form of signal is taken out from digital to analog converter. Then it will be able to actuate the actuator, or you can say driver, right? So this is the block diagram of hardware that we have in an embedded system. Basic software structure. Okay. So we have different software structures. Okay, let me complete this part first, like basics of microcontroller based embedded system. So microcontroller based embedded system may have a couple of sensors at the input, then sensor conditioning, then microcontroller unit for doing calculations, processing the data, and then doing this control mechanism, and finally it would produce the output, which is given to the interface and actuator. So which is very much similar to this one, right? So the block diagram is almost similar, but the thing is, here I'm using multiple sensors. So microcontroller based embedded system can do multiple measurements, and based on that it can do certain tasks. It can do some tasks. So I need to list out some of the embedded system examples which are microcontroller based. Now it's your turn. Open the chat box, write your own idea. What I want is the list, which you can say it as like example of microcontroller based embedded system. microcontroller based embedded system. So everyone need to write one microcontroller based embedded system. Your time starts now. Mobile, okay. Camera, okay. One person, one example. Deepika, one is sufficient. Now, today I will not see the roll numbers. Today I will see the answers. Those who answer, their attendance will be marked. Digital watch, very good. Shraddha Mirgane, very nice. Washing machine, the example which I have given, copied. Next. Those who will write the comment, those who will write the example of embedded system, tablets, okay. Microwave oven, okay, good. GPS, okay, good. Driverless car, okay. DVD player, very nice. Television, good. Calculator, of course. Robots, okay. MP3 player, okay. Drones, okay, good. ATM machine, okay. See how many examples we are able to list actually. So if you try to understand any one of the example, you can prepare a short note of 10 pages on every single example. Like if someone say drone, right? So it will what things are required. If you start listing, you will write 10 pages note on it. Vending machine, correct. Printer, correct. Vehicles, okay. Traffic signals, good. Auto tailor machine, okay. Anything else? Washing machine, home security system, correct. Gaming console, correct. Digital camera, somebody has written already, okay. Yeah, but don't worry. But if it's getting repeated, no, don't worry. You what thing comes into your mind, you just keep pasting there. Industrial robot, good. Yeah, when it comes to the examples, no, because in examination, if it is going to be offline, sorry. Basically, the question would be, what is an embedded system? Explain with example, right? So there should not be any kind of thing like you are remembering and you are not able to recall the example. So they may ask you to write 10 examples, list 10 examples of embedded system. So you should be able to write all those examples immediately and quickly. Right, so refrigerator, correct. Dishwashers, okay. So all of them are actually a good examples of embedded systems. But one restriction on embedded system, I told you, if the embedded system is designed to perform a particular task, it will not be used to perform other tasks. Right? For example, camera cannot be used to camera cannot be used as a refrigerator cannot be used to take or capture the images, right? So this is how the embedded systems are defined, which will have some hardware, some software, and it's performing some task as nothing but your embedded system. Okay, so with that understanding, actually, I have a plan of this software-based embedded system tomorrow. Maybe in the next lecture we will discuss software-based embedded system. So let me quickly tell you what we have discussed today. As this different components of embedded system is done, then basic structure of embedded system hardware is done. Actually, I wanted to cover this one later on, so I will put it next. I will shift the slide, and this one is also done. So basic of microcontroller based embedded system is done. So tomorrow in the next lecture, we will talk basic structure, software structure, then basics of Linux based embedded system, and rest of the things we will discuss in the next lecture. Right. So by the time, if you have any doubt, you can ask. For tomorrow's drive, I think the instructions are reached. You need to have brush up on the knowledge of C, C++, then data structure. Then you should be clear with all the concept that you are using in a project. I hope all of you have gone through the company profile, and I hope all of you have applied for the 4th position, which is quality assurance position. How many of you have applied for tomorrow's off-campus drive? Okay. Snehal Duchar. Okay. So most of you might have enrolled for that, but do you know for what positions the hiring is going on? You might have seen that in the job description, right? In that trailing mail, you will find all those 4 positions. You check it out. Don't dare to apply for software developer or etc., because their hiring process will be going to be tough. So what I feel is, if you are really know the coding and development part, then you can apply, no issue with that. If you don't know, please go for 4th option and try to search try to see some videos on the YouTube which are readily available for quality assurance, quality testing, right? So software testing, I want you to apply for tomorrow's drive, right? So if you have any doubt, you can ask. Otherwise, you are allowed to leave the meeting now.